Okay, so we'll start now, and what we'll do is, before we start the next topic, just as revision, I'm going to do one of the questions from the workbook yesterday. Yeah, 185. Yeah, which one would you like to see? Well, she has one question. You want me to do that one? Okay. I can't remember exactly the way I gave it to you yesterday. What was it? dy over dx equal to... Here, yeah. You want me to do that one, not one from the workbook? You can do these workbook ones? Did you try these workbook ones? Okay. Why not? Don't know. Yeah, right. All right. Well, I'll hold on to this for the next one. Okay, so I'll do, in that case, I'll do the one from yesterday, so. Okay.
Today we have 1 hour or
2.
What?
Was that related to my 2 hours?
Yeah.
2 hours.
Our schedule is we got 1 hour.
Like, 2.
Like we thought we had 3 hours chemistry, physics, and then 1 hour to you, and then 1 hour break.
We're in math class right now. Wait, where are you? No, it's now.
See?
Oh,
We thought it was
Yeah.
are you serious?
Yeah.
Our schedule says 12 to 1.
We're like in class right now.
So that's what, okay.
It's not like they would show up, they missed 3 hours of biology.
Okay, all right.
It was at 12.
Who told her? Whatever. All right, I'll go do that one now for you. Jojo, can you read out the question? What was it? dy over dx equal e power y times log x. Oh, I should turn the lights off now. Okay, you can all see that fine?
Yes.
Yep. Okay, so this is like the one they had in the exam recently. Hey, you're asked. This is like the one they had in the exam recently, and we'll go through it. So separation of variables. So I'll do my swaps.
You can do it in one step instead of like...
Yeah, I'll just do it in one step here. So the log x goes down on the left. No, that's not right. The log x stays up on the right, and I bring the dx up, and then the ey goes down. So let's see that. Yep, like that. Happy? Now, I should make my life a little easier on the left. Rather than saying 1 over ey, what should I change that into? Any ideas? Yeah, e to the minus y. So at least I'm not dealing with a fraction now. You can, yep. Okay, now I need to integrate. So integrate on the left and integrate on the right. Happy with that? Now on the left, there's not really any problem here. We did this in semester 1. Yeah? So what do I get on the left?
Log of e to the y.
What's, no, try again. On the left, antiderivative of e power minus y.
Isn't it?
It's not log. No, come on. Antiderivative of e? E. So e minus y? It'd be minus e power minus y. Yeah, why are we? Antiderivative. Well, this is for e, they're very similar, both.
So you don't add anything to the y?
No, what were you thinking of adding to the y? If you want to be a little bit more precise here, I'm actually dividing by, but dividing by minus and multiplying by minus the same thing. Okay, so if you want it to be more precise, it's actually e power minus y all over minus 1. But dividing by minus 1 is the same as multiplying by minus 1, so it just looks neater this way. And of course I should take that minus from the left, bring it to the right. I won't worry about that just yet. So now I need to take care of the integration on the right, and this is the problem. So I'll do this on a separate page, the integration of log x. And do you remember, what did I say I needed yesterday? By parts. Okay. And let me just copy the question over. So I'm just going to look at the right hand side by itself. So, uh-oh, I don't think it likes question marks. Yes, I see my problem. Okay. Right, that should be okay now. There, that should be okay now. Yeah. So, what rule? By parts. Now, the problem here was there's only one function, log x, and by parts you need to have two functions. So you need to put in a second function, or really there is a second function there, but you can't see it. What is it? 1. So the first thing I'll do is I'll rewrite this as integration of 1 times log x dx. Now we have to think back. Is this the correct order? Yes or no? Is it? No. Remember, what word do we need to think about? What is the word? The week holiday was really that long, huh? L-I-A-T-E. Remember this? L-I-A-T-E. Remember this word? So what does the L stand for? Logs. So log always needs to go in the front. So in fact I should write the 1 at the back. Like this. Yes? Yeah. Okay. Now, with that in mind, I can now make my substitution. So what letter do we use for the log x? Which part is that? The f or the g derivative? Remember, we have the f and the g derivative. So you say f equals log x and g derivative equals 1. Yeah? So you can use your rule now. So I hope you remember the rule. The rule is it's equal to fg minus f derivative g integration. Yeah, we remember doing this? So I have f equals log x and g derivative equals 1. So what does f derivative equal? If f is log x, f derivative is 1 over x, very good. And what will g equal if g derivative is 1? Yeah, very good. So now I can start to put into my formula these results. So it's just a matter of copying the formula and then replacing each part. Okay, so let's do that. The f, what did I say the f was? The f is log x. And then the g is x. And then the f derivative is 1 over x. And then the g is x. Okay. So now I can tidy this up a little bit. The 1 over x and the x cancel. You see there in the integration? See the 1 over x and the x? They can cancel. So it actually makes it a much easier problem. It's just actually the integration of 1. That's nice and straightforward. What's the antiderivative of 1? X. So let me just replace that now with x. And so I have the answer. There's the antiderivative of log x. It's log x times x minus x. Okay? Or I'll write that a little bit nicer or a little bit clearer. X log x minus x, and if you want you can take the x out. Yeah? Sure. So there you go. You can take the x out of x log x minus x. So you have x times log x minus 1. Okay? So now I can go back to the question and put that in. Okay, so go back to the question. Okay. And then on the next line, I have antiderivative of log x was x log x minus 1. Okay. Now, that's nearly finished, but I'm not looking for, well, what am I looking for here? I'm looking for y. So I need to do some, what's wrong? What's wrong? I'm looking for y here. So what should I do? Log both sides. But just before I do log both sides, yeah, I'll take that minus over to the left. It'll make my life a bit easier. And now I can put log on both sides. So log goes here, and then log goes on the right. There you go there. Put log on both sides, no problem. So on the left, I can cancel the log and the e. So I'm just left with minus y. And then on the right, if I want to make it a little nicer looking, I can multiply this minus into this. So minus times minus 1, plus 1, and then minus times log x, minus log x. So to make it more presentable, I'll do that. So I get this result. Okay, nearly finished. 2 things left to do. What should I do now? Yeah, I'll take that minus now on the left, bring that over to the right, and then there's one thing I left out, plus c. Yeah. Now I should have put the plus c actually in when I integrated this. So really, if I want to be more careful here, the plus c is actually added after this line. And then after that, I put log on both sides. So actually the c should be inside the log. So I'll put it inside the log. Okay, there we go. Inside the log. There we go. Okay, so that's the answer. So this example here, you can see it's tricky enough actually. And nobody got this right on the exam. And the reason nobody got it right is because nobody, well, most people weren't practicing enough questions, because this question actually is in your workbook from earlier in the semester. So actually there was a question in your workbook that asked you to integrate log x, and that was exactly what was on the exam, and I'm sure nobody did that question because it was near the end of the worksheet and they figured if I did some of the questions on the worksheet I can probably do them all if they were wrong, so nobody got this right. Okay, so if you don't do the worksheet questions, that's your problem. Okay, I think this pretty well covers what we started yesterday, the ordinary differential equation. So what we're going to look at today is practical problems of it. So if you open your book, it's on page 187, and it's very similar. The only difference is we have a little story and we have to change the story into an equation and then just solve the equation like before. Okay, I know. But there's just keywords to look out for, okay? So we'll have a start with this now. 187. Okay. Now, this topic here will be very important for your project. And the reason it's very important for your project because there's at least two parts of your project whereby you have to look up the definition of a term from chemistry and you have to convert the definition into an equation. So pretty much the type of stuff that you're doing here. And just before we start looking at that, Jojo, you've been using your phone so much in class. I haven't said anything yet. Put it away or I'll take it. Yeah. So just before we start looking at examples, I just want to give you some key vocabulary to help you out here, okay? First, keywords. So, some keywords to help understand these problems. Okay, so the first one, rate. So anybody, do they have any idea what rate would mean in a maths sense? If I use rate in maths, what does it mean? The rate of something. Or even just from English, what way do you understand the word rate? Yeah, in physics, okay, what's physics?
Something per second.
Yes, it's usually per second, so it's usually something changing per time. So rate basically means change. How fast something changes, okay? So from physics, you know, speed, velocity, these are rates. You know, how quickly a car is changing its position. Other examples of rates, maybe you might have if you had something leaking, like a bucket, the water was leaking out, how quickly it's leaking out. That's, you would say, the rate at which it's leaking out. Okay, so rate means how quickly something is changing. Do we understand this word? Okay, so rate, how quick something is changing. And you know, examples would be like speed. What other ones have you done in physics or chemistry? Yeah, decay, very good, yeah. Decay of, let's say, uranium-238, is that the one you did? Ah, yes, no, yeah. Etc., etc. Rate of what, yeah?
Currents.
Yeah, currents, yeah. Like, you mean electric or some other type of currents? Yeah, well, I think we all have the idea now what rate means. But in the mathematical formula, what does rate mean? In fact, rate means derivative. So if I say rate, it's like saying derivative, okay? So this is, in fact, the derivative. So the rate at which y changes per unit x. So for example, if I wanted the rate of change per time, I wouldn't write dx. What would I write instead? dt. You know? So for example, decay, you know, decay of U238 would be something like du dt, because it's the how much uranium you have per time. Now, this is decaying, so it's actually decreasing. But we can have things that are increasing, like speed as well. So it can be both directions here. But the key thing here is rate means how quickly it's changing, and it means derivative for us. Okay. Next word. Okay. Proportional. And I hope you did this one now from physics or chemistry. Any idea now about this one, proportional? Have you done this one before, proportional? Oops.
So as one increases, the other increases.
Yeah.
Values of a relation.
They're related, yes. One increases, the other increases. And what is the type of relationship though? Direct relationship. One increases, the other increases. Yeah. Oh, the key word I was looking for was linear. Okay? So if two things are proportional, it means there's a linear relationship. Okay? So like if you double one, then the other one should double. If you increase one by 10%, the other one should increase by 10%. Okay? Or decrease by 10%. It should work like this. Okay? Now, let's see, do I remember how to get the symbol up? No. Okay. Do you know the symbol for proportional? It's kind of like the alpha symbol. How do I get it on this again? I'm thinking of doing that. I thought it was just prop. No. Pro? No. Google's our friend here. What laws have you done in chemistry or biology or physics where the word proportional is used? Gravitational, yeah. In chemistry, I'm sure you've done, I know of one that you've done in chemistry. Boyle's law. Would you have done Boyle's law in chemistry? Gas laws, yeah. So what is it like? Volume is proportional, inversely proportional to pressure. You didn't do it yet? Okay.
It was just before, no, we did it just before the exam.
Got it there. Doesn't matter. You know what it is anyways. Anyways, the reason I'm asking is in case see if you've seen the symbol. So there it is, proportional symbol there. Okay. So if y is proportional to x, this means they have a linear relationship, and so we can write y equals kx. So that k is actually called the constant of proportionality. It basically tells you how quick a change in one would cause a change in the other. So for example, if k was 1, then it means the relationship is just identical. Y is the same as x. If y increases by 10%, x increases by 10%, and whatever x is, y is the same thing, because y equals x. You know? But you could have something like y equals 2x or whatever. But even if y equals 2x, a 10% increase in x still makes a 10% increase in y. The only difference is, for example, if x was 10, then y would be 20. If I increase x by 10%, so 10 becomes increase by 10%. No, increase 10 by 10%, 11. And then y would become increase 20 by 10%, 22.
Oh, I thought 10 by 20%.
No. Okay, so these are actually the two most important words for this topic: rate and proportional. And probably with just those two words you can actually do nearly or all the problems. The only other thing to say before we start is the sign of this k.
Negative.
Yeah, if it's positive or negative. If k is more than 0, this means an increase in x by 10% would mean y would increase by 10%. Okay? If it's positive, so everything is nice there. But if it's negative, it's a little bit different now. If k is negative, as x increases, y decreases, because y becomes more negative. You know, like for example, let's take k is minus 2. All right. So if x is 10, what's y? Minus 20. And if I make x bigger by 10%, so if x becomes 11, what does y become? Minus 22. So it's gotten smaller. It's gotten more negative. It's decreased. It's gone further negative by 10%. So a positive k means an increase in x, means an increase in y, and then a negative k would mean an increase in x means a decrease in y. And that's the other important idea to have here. So if k is positive, this means an increase in x results in y increasing, and if k is negative, then a increase in x results in y decreasing. Okay, are we happy with that? Yep. So that's all the key ideas now. This, with what we did yesterday, will give us whatever we need to solve the problems. The idea of rate, proportional, and the sign. Okay. So what I'm going to do as an example, I'll probably do the first one here as an example. So can you all see the question 1 on 187?
Yes.
I have it here, yes. I'll give it to you now. Okay. Now, do you need to write this down? Did you write it down yet? Just write down just a note about the 3 key ideas, okay? Rate, proportional, and the sign. So just write something down. You don't have to write the whole thing down, okay? Thank you. Okay, so once you write that down, look at the first one there. I'll do it now for you. Okay? Yeah. Did you all have a read through it? Just read through it once and then I'll do it. Okay? Okay. Will we look through it now? Yep. Okay. So I need you to read through it for me. So can you read through it, please? Go ahead. Yeah, read through it.
The question itself?
Yeah, I want to hear it.
An example of radioactive materials.
Yes?
The rate of decay.
Okay, so we'll stop at each keyword. So in a sample of radioactive material, the rate of decay
Or decrease.
Yep.
The number n of radioactive nuclei is proportional to the number of.
Okay, so we'll have to take that a bit by bit. So the first thing, the rate of change for the n, capital N, yeah?
Yeah.
Okay. So that's dn dt, because it's the rate of change of n per time, is proportional to
The number of radioactive
material n that remains.
in the equation.
Yeah. So basically, whoops, no space there. Basically, we get this equation from reading the sentence. dn dt is proportional to n. So all I've used so far is my idea of what rate means. Now I should look into what proportional means. So what can I do with this proportional? Well, I can drop the proportional and add in a constant. Okay. Now, it's not a big deal if you don't put the correct sign here, because k could be positive or negative. But it's nice if you can put the sign in front to show which way it's changing. So which do I need here? A positive or a negative? A negative, because it's a decrease problem.
Isn't it always negative?
No, it can be like, I think there's population examples there where you talk about the population increasing. So it'll be positive then. So I get this equation. Now that's not a very difficult problem. What's the name of this type of problem? It's ordinary differential equation, ODE, what we did yesterday. So what technique do we use to solve it? Yeah, so we will use separation of variables now and get, so I'll bring the n down on the left and then bring the dt up to the right. So I get dn over n equals minus k dt.
Yes.
Happy with that? Okay. What's next? Integrate both sides. Now, 1 over n. What's the antiderivative of 1 over n? Yeah, log n. An antiderivative of 1 or k, or whatever way you want to look at it, it'll just be t. So I get minus kt. And I should be careful. I'll put the c in at this stage, rather than waiting until the end. I don't want to make any mistakes.
Why is it negative kt?
It's because it's minus k integrate dt. You see here?
You took out the minus k?
Yeah, you can take constants outside of integration, but if you didn't like that, you can put the integration around the minus k if you want, like that. If you prefer, it doesn't matter. So it gives me the same answer anyways, log n equals minus kt plus c. Now I don't want log n, what do I want? Yeah, I want n, so I need to put an exponential on both sides. So I'll just do this in one step. E will cancel the log, and so I get this result. Whoops. N equals e power minus kt plus c. So it's nearly finished. I just have to find the c. And if you remember yesterday, I'm going to separate this c out in the front as e power c. It'll make my life a bit easier. Now, I'll use the information they give me. I think they say in the book that at the beginning there's n0 nuclei. Does it say that in the question?
N equals n0.
Yeah, n equals n0 at the beginning, initially.
T equals 0.
So t is 0 then. So I get, just copy this, replace n with n0, and replace t with 0. I get n0 equals that. But what's e power 0? 1. So I get ec equals n0. So I just go back to my original, just a line before, and now I replace ec with n0. So I have the full solution now. n equals n0 e power minus kt. So I think that's important enough to get its own line.
These are questions on the exam?
Yeah, just like this on the exam.
Copy.
There we go. So there's the solution for the first question.
Will it never be a part A, right?
No, it comes up in A and B. Okay, are you happy with that? So really, I think one example is enough because the key here is just changing the story into an equation. And once you can do that, it's basically just like the problems we've done yesterday. There's no difference. There's just this one extra layer between the question and the final answer, which is changing the information into an equation. Okay? Are you happy with that? Okay, so what I want you to do for a few minutes is try the worksheet then. Okay? So I've just done question 1 for you. You'll notice that they like to give these types of problems whereby the answer is usually in E. Not always. Usually the answer is in E in the worksheet there for these, okay? But in the exam, I think 50% of the time they give you a question where the answer is like this with an E function, and 50% of the time it's not. But it's still a popular choice that they like to give. And the reason for this is because in physics and in chemistry and biology, a lot of problems have this solution. So this is why it's so popular, because it's a popular problem in other science subjects. Okay? So try the worksheet there for a few minutes.